Okay, let's unpack this. Have you ever, like, strolled through your neighborhood, admiring those big, majestic trees, and really stopped to think about the hidden dramas, the stuff unfolding beneath the bark?
Oh, yeah. The quiet battles, the profound ecological challenges happening right there.
Exactly. These global sagas playing out, sometimes literally in our own backyards. And today, we're getting into one such compelling story, and it's, well, frankly, a bit heartbreaking. Elm disease.
It really is. And it's so much more than just a tree sickness, isn't it?
It absolutely is. It's
Yeah.
like a living testament to, global spread, the unintended consequences when humans get involved, and nature's complex, sometimes really fragile resilience.
Hmm.
And this particular exploration, this deep dive we're doing today, it actually kicked off because of some truly fantastic notes, really comprehensive stuff.
Oh, right. A student sub.
Yeah, meticulously compiled by two incredibly insightful students, Kesser and Steen. They did this right after their summer vacation for their nature and innovation class.
That's great. What did they notice?
Well, their keen observation of wilting trees just in their area sparked this whole conversation with their professor, Mr. Hendricks. And honestly, their excellent work gave us such a rich foundation for our discussion today.
That's fantastic. Good for them for being so observant.
Totally. So our mission for you, our listener, is to kind of distill the most important nuggets of knowledge, the surprising facts from these detailed sources, give you a valuable shortcut to being really well informed about this devastating plant disease that has, quite literally reshaped landscapes across continents.
And what's fascinating here right from the start is just how profound the significance of elm disease truly is. It really stands as a stark classic example
Of what
of
exactly?
the catastrophic consequences that can pop up when we as humans inadvertently, help spread these plant pathogenic fungi from one continent to
I don't
another.
know, moving things around without realizing the stowaways.
Precisely.
Ugh.
And just to give you a sense of the scale we're talking about, this disease has killed millions, literally millions, of elm trees in Europe over the last 50 years or so.
Millions. That's staggering.
It is. And here in Denmark, which is the specific context Kesser and Steen were looking at, thousands upon thousands of elms have been lost since the disease really arrived around 1979.
Wow, since 79.
Yeah. And at its heart, this isn't just a simple infection. It's a complex and lethal symbiosis. That's the term used in the notes.
Symbiosis. But doesn't that usually mean, like, beneficial?
Often, yes, like bees and flowers, mutually beneficial.
Hmm.
But here it involves both a fungus and an insect, and it's more like a deadly partnership.
Hmm.
The benefit is entirely for the disease-causing organisms, and it proves absolutely devastating for the poor elm tree.
A partnership in destruction.
Hmm.
Okay, so let's start where Kesser and Steen started with that real-world observation.
That makes sense.
That observation really highlights the power of just noticing what's around you, doesn't it? After their summer vacation, these students, Kesser and Steen, came back and saw something significant right in their local area, their neighborhood.
Yeah, the notes say they saw quite large trees withering away, losing leaves and dying.
Think about that attentiveness. To spot such a subtle, maybe, but profound change in the everyday landscape. That's what really sparked this whole deep dive.
It really is impressive. And their professor, Mr. Hendricks, his reaction was key too, right?
Absolutely. The notes mention his praise, calling it a very interesting observation, and he immediately hypothesized it was elm disease that was, quote, raging the landscape here. He even mentioned an expert coming from Copenhagen University.
So it validated their observations straight away and set the stage for a deeper look.
Exactly. So let's unpack that core definition a bit more. You mentioned this symbiosis.
Right. It's defined as a cooperation symbiosis between a fungus and an insect. And like we said, usually symbiosis implies mutual benefit. But here, the benefit is squarely with the fungus and the beetle, and it comes at the tree's expense.
Making it incredibly effective, unfortunately.
Tragically effective. And it really is a classic example, as the notes stress, because it just powerfully illustrates the dire consequences when human actions, even seemingly small ones, help these plant pathogens jump continents.
It's a recurring theme, isn't it? Ecological disruption from our interconnected world.
It is. And the tangible consequences are multifaceted, really impactful. First, you've got the huge aesthetic impact.
Yeah, you can picture that.
Imagine these beautiful, large, mature trees just vanishing. from natural landscapes, from city streets, parks. It leaves a huge void.
You can't just replace them overnight.
Exactly. Finding other tree species that can immediately fill the elm's unique ecological and visual role, that's an immense challenge. You don't just swap out a 100-year-old elm for a little sapling and get the same effect right.
Not at all.
The core insight here is that losing a single species like the elm creates this ripple effect, not just locally, but on the whole fabric of our communities. It forces us into these costly long-term adaptations.
And speaking of costly,
Yes. Secondly, there's a colossal economic burden. Many municipalities face this large and economically heavy task felling, disposing of vast numbers of diseased trees.
I bet that must cost a fortune.
Think about it. Specialized labor for safely taking down big, possibly unstable trees, the heavy equipment needed, grinding the stumps, and then the complex logistics and expense of proper waste management to stop it spreading further.
Yeah, that's a huge drain on public resources. Money that could go elsewhere.
Precisely.
And looking specifically at Denmark, the disease arrived around 1979.
That's the pinpointed entry time, yes.
And from there, it was swift and extensive. The notes say it's now found over most of the country.
Pretty much everywhere now.
And thousands of elm trees already killed. That's just devastating for the landscape.
It is, and what's particularly challenging and maybe a bit disheartening is the clear reality stated in the notes. It is insurmountable to eradicate elm disease once it's really taken hold.
So eradication is off the table.
Pretty much, yeah. Once established, the enemy is just too pervasive. So the objective had to shift quite dramatically.
From fighting to managing.
Exactly. Instead of eradication, the focus now is on slowing its advance. The notes use the Danish Sinkedens fremtræng. This allows for the gradual replacement of elms with other species.
So it's like a managed adaptation, a strategic retreat almost.
That's a good way to put it. It acknowledges the immense power of this tiny fungus beetle partnership. It's a pragmatic acceptance, really, focusing on what can be done to mitigate the damage rather than trying to win a battle that's likely already lost.
Okay, that sets the scene. Let's trace the path then. How did this thing go global?
Right, the global history. To understand the scope, we have to go back to its origins. The notes say it originally stems from Asia.
Asia. Okay.
And what's truly fascinating here is thinking about how a pathogen, which might have coexisted fairly stably with its native hosts in Asia, maybe local elms there had developed some natural resistance over millennia.
Right, they evolved together.
Exactly. But then human activity introduces it to new vulnerable populations elsewhere. Trees that have no evolved defenses, suddenly it becomes this global threat.
And the first sighting in Europe was?
Holland, around 1919, which is actually where it gets its common English name, Dutch Elm Disease, or DED. That's useful if you're searching online.
Dutch Elm Disease. Okay, got it.
And just 3 years after those first cases, a big step. The fungus Ophiostoma ulmi was identified as the cause. That was crucial early scientific work.
So they knew what they were dealing with fairly early on.
They identified the fungus, yes, but then came the really dark turn, especially for European elms.
What happened?
That original fungus, O. ulmi, once it arrived in Europe, met the elm bark beetles and thus got the perfect vector.
The delivery system.
The perfect living delivery system. Like a mosquito for malaria, these tiny beetles became the ideal biological couriers, carrying fungal spores from tree to tree without even knowing it.
And the result?
Rapid and devastating. The disease spread quickly and many elms died. Just swaths of dead and dying trees across Europe.
Wow. And then it jumped the Atlantic.
It did. The fungus was spread to the North American continent with infected elm logs.
Human trade again?
Yeah.
Timber industry?
Directly linked. And tragically, what they discovered there was that the American elm species were even more susceptible than the European ones.
And worse.
Even worse, no co-evolved resistance at all. So the disease dealt an even harder blow for the landscape and cities across North America. An almost unimaginable scale of loss, profoundly changing ecosystems and the look of towns and cities.
So that was the first wave, Ophiostoma ulmi. But you said earlier something changed.
Right. Despite that initial devastation, many elms in Europe actually survived that first wave. It seemed for a while maybe the worst was over.
I'm gonna hope.
Perhaps. Around 1960, an English pathologist assessed the damage and felt the future danger was less than feared, but added a crucial caveat: unless the disease quite changes its behavior. And incredibly, the notes say, this should prove to be a correct prophecy. Which raises that important question. Did the fungus just change its behavior, or was it something new entirely?
And the answer was?
The answer came quickly. In the late 1960s, the disease flared up again around southern English ports, and this resurgence was directly linked, once again, to imports.
Yeah.
Yep. Infected elm logs from the USA this time.
So the disease came back from America.
That's what it looked like initially. It was quickly confirmed these were new, highly aggressive, infectious races of the fungus. They were termed NAN, North American, and EAN, European Asian, based on where they were found. Scientists thought they were just more aggressive strains of the existing fungus.
But they weren't.
No, this is a critical piece of the puzzle. Subsequent, more in-depth research revealed it was actually a completely new species of fungus altogether, Ophiostoma novoumi.
All new species. Wow.
Yeah, introduced from Asia at a later date, likely bypassing earlier import restrictions because people thought the original disease was already present. A significant reclassification. A fundamentally different and much, much nastier foe.
Ophiostoma novoumi. That's the real killer then.
That's the one. It has completely outcompeted the original species. It's just so much more aggressive, spreads faster, infects more efficiently. It has largely replaced oomi.
This is the one that hit Denmark hard.
Yes. This is the fungus that has ravaged Danish elms since the 1980s. And the notes specify which elms are particularly vulnerable. Store-bladed elm, Ulmus glabra, small-bladed elm, U. carpinifolia, and scaremel, U. laevis. They're all highly susceptible.
Okay, so let's bring it back to Denmark's experience, that localized timeline. It wasn't completely new in the 70s, right? There was an earlier incident.
That's right. The notes mention a single attack in 1955. And interestingly, back then, they succeeded in removing the disease by felling the attacked trees.
So it was containable initially.
It suggests that maybe those initial, perhaps less aggressive outbreaks could be stopped with quick, decisive action. But the landscape changed, didn't it? The new threat, O novoumi, was different.
And people started realizing the danger.
Yes. From the mid-1970s, there was growing awareness of the danger posed by this new aggressive species making its way across continents.
And then it came back properly.
It did. Elm disease was again detected in 1978. This led to a national combat strategy based on sanitation, basically trying to clean up, remove infected wood.
Did that work? For a while.
The notes say it seemed to keep elm disease down until the late 1980s. But by 1985, a noticeable increase in distribution was observed, a warning sign, especially strong in East Jutland, North Zealand, and Copenhagen.
And then the 90s hit.
Yeah, the 1990s were when the floodgates really opened, elm disease spread rapidly, and fighting it became insurmountable in many cases.
It's too much too fast.
Exactly, and the scale is just staggering when you look at the examples. Take DSB, the Danish railways.
Right, you mentioned them.
Until 1989, they were diligently felling and disposing of diseased trees as recommended. But after that, the disease spread so quickly along the railway lines, it became impossible to manage.
So they just stopped trying.
Pretty much. Dead trees were only removed if they were in immediate danger, like falling on tracks or just during routine maintenance. It shows how quickly the problem overwhelmed even a big, organized entity.
That's a stark image. In Copenhagen.
Even starker. The progression of figures paints this picture of an accelerating crisis. Between 85 and 88, maybe 50 attacked trees per year.
Okay. Manageable, maybe?
Then 89 to 92, it jumped to about 200 trees a year.
Quadrupled.
Then 1993, 750 trees.
Whoa.
And then 1994, 2,000 diseased trees. At that point, it became officially impossible to keep up and dispose of all diseased trees. The city was just overwhelmed.
2,000 in 1 year.
And the result? The note states starkly that after 2000, most elms had disappeared from Copenhagen.
Just gone. From the cityscape.
Transformed. Where majestic elms once stood. Gone. But how did this tiny, unseen enemy manage it? What are the actual mechanics of the attack?
Yeah, let's get into the nitty-gritty. How does it spread so effectively? The beetles, right?
Primarily, yes. In most cases, elm bark beetles are the ones that spread elm disease. They are the vectors, the couriers.
Okay.
Understanding their life cycle is key. They breed under the bark on all forms of weakened and recently dead elm trees. And crucially, this includes trees already sick with elm disease.
So the disease creates the perfect breeding ground for its own carriers.
Exactly. A vicious cycle. Diseased trees become nurseries for more disease-carrying beetles.
Clever, in a sinister way.
It is. And the moment of transmission is precise. When a new generation of adult beetles fly out from an elm disease tree in the spring, they carry fungal spores on their mouth parts and legs.
Just hitching a ride.
Tiny carriers loaded with potent spores ready for their next flight.
And how do they infect a healthy tree?
It's their feeding behavior. The beetles make a gnaw in branch forks of finger-thick shoots on healthy elms.
Why there?
They need nutrients for mating and egg-laying. This specific action, this little feeding wound, is key. It creates an entry point.
Right into the tree's system.
Directly. The fungus's spores are transferred to the wound, where they germinate and penetrate into the outermost xylem vessels.
The tree's plumbing, basically.
Exactly, the water transport system. Once inside, the fungus's mycelium, its thread-like body, grows and forms new spores which then divide yeast-like. Rapid multiplication.
Colonizing the pipes.
Pretty much. Further spread happens via transport with water currents in the vessels, and the mycelium also grows across between vessels, invading the whole network.
So what does this all mean for the tree?
It means a rapid internal systemic takeover. The fungus quickly colonizes and effectively shuts down the tree's water transport system from the inside out.
Wow, but it's not just the beetles, is it? The notes mentioned roots.
Correct. Beyond the beetles, the fungus uses hidden highways. It can spread from tree to tree via the root systems.
Underground spread.
Yes. And this process is especially fast if the trees are closely related, like, say, clones of elm trees in an alley.
Why clones?
Because their root systems often graft together naturally. They fuse. So the fungus has a direct subterranean pathway from an infected tree to a healthy neighbor. No beetle needed. Silent transfer.
An invisible network of death.
A bit dramatic, but essentially yes. But unfortunately, we humans still play a big role, often without meaning to.
How so?
Unfortunately, humans still spread the disease by transporting fungus-infected pieces of wood, which can also contain beetles. Our responsibility is huge.
Like moving firewood.
Exactly. The notes give a stark example from many Danish small islands. These islands are usually too isolated for elm bark beetles to fly there. Naturally protected, you'd think.
But they got infected anyway.
Yes, because inconsiderate people have brought elm firewood with them to summer houses.
Oh no, just for a campfire.
Seems harmless, right? But that firewood, potentially hiding beetles or spores, introduced the disease directly into these isolated ecosystems.
That's devastating. A single log.
It really raises that important question. How do we get the message across? How do we educate people that seemingly innocent actions can have such massive ecological consequences, upsetting decades of natural balance?
It's a tough one. People just don't think. Okay, so we know how it spreads. What should people actually look for? What are the signs?
Right, the symptoms. Elm disease shows itself through some pretty distinct visual clues. Distress signals from the tree.
Like what?
The most obvious initial ones are wilting of leaves and shoots in the upper crown. The leaves curl up and become grayish-green or brown.
Do they fall off straight away?
Interestingly, no. They typically remain on for a few weeks before falling, so there's a window for observation.
Okay. Anything else distinctive?
Yes. The disease shoot axes dry out and bend, so they resemble bishop staffs. That curved top, it's quite a memorable visual.
A bishop staff. Got it.
And gradually, as the fungus spreads inside, still larger parts of the branch systems die. The crown visibly thins out.
Does it always start at the top?
Not necessarily. The pattern can vary. It might begin in single branch systems, which often points to beetle transfer. Or if it's spread via roots, it can appear in the entire crown at once, almost like a sudden whole tree sickness.
Knowing the pattern might give a clue to how it got there.
Exactly.
Are there internal signs too? Things you see if you cut into it?
Yes, definitely. Beyond the visible clues, there's crucial internal evidence. If you take a cross-section of a branch with wilting symptoms, you might see, maybe with a magnifying glass, dark spots in the springwood in the outermost annual rings.
What are those spots?
That's the fungus. Those spots can merge together and resemble brown rings, staining the wood. It's a distinctive sign of the fungal invasion in the vascular system.
Wow.
And that discoloration is also visible just under the bark as strips or flames in the summer running along the infected branches.
Flames under the bark. Another vivid image.
And of course, under the bark on the trunk and larger branches, you might see the elm bark beetle's gallery systems. Those tunnels carved by the larvae. Direct evidence of the vector.
So with all those signs, is it usually obvious it's elm disease? Or could it be something else?
Well, other things can cause wilting and discoloration, so for absolute certainty, you'd need to isolate the fungus on an artificial nutrient substrate in the laboratory, get it identified properly.
Lab confirmation.
But the notes confirm that, as a rule, there will be no doubt when an elm tree dies of elm disease. That specific combination of symptoms, external and internal, is usually pretty definitive.
Okay. Now, you mentioned something earlier that sounded really counterintuitive about how the tree actually died.
Yes, this is where it gets really interesting and quite tragic, actually.
It's not the fungus directly killing it.
Not exactly. It turns out it's mostly the tree's own desperate but ultimately self-defeating attempt to survive that leads to its death.
How does that work?
Well, the fungus does excrete a toxin, a poison, that causes the leaves to wilt initially. That's part of the distress signal.
Okay.
But the primary fatal mechanism is the tree's effort to delimit the infection, to stop it spreading.
So it tries to wall it off.
Exactly. It forms tyloses and gummy substances inside its vessels. Think of them like internal plugs or blockages. It's trying to physically stop the fungus moving through its plumbing system.
Makes sense as a defense.
It does, but tragically in doing so, it also shuts off the water supply to the crown.
Oh, no.
It's like applying an internal tourniquet that's too tight. It starves the crown of water, and the tree often dies from dehydration, essentially. A self-sacrifice that goes wrong.
So its own defense kills it.
In many cases, yes. Historically, with the original, less aggressive fungus, Olmi, if the tree reacted fast enough, it might only lose a branch or part of the crown. It could compartmentalize the infection and survive.
Some resistance was possible then.
Yes, some elms showed resistance. But the tragic update, according to the note, is that the elm tree's reaction is just too slow when facing the new aggressive O. nova ulmi. They can't wall it off fast enough. The fungus overwhelms the defense.
That's incredibly sad. The defense becomes the fatal flaw.
It really is. And this connects to debunking a common myth you might hear.
What's that?
One often hears the claim that young elms do not get sick because they are too small for the beetles to lay eggs in them.
Right. I think I've heard that. Is it not true?
It's a misconception. The factual correction is, all elms, regardless of age and size, can be infected with elm disease.
Okay. So why the confusion about size?
Well, it's true that only elms with bark of a certain thickness can be used by elm bark beetles for eggling. The bark needs to be thick enough for them to bore in and make galleries for their larvae.
Okay.
But here's the crucial point. It's not eggling that transfers elm disease, but rather feeding gnaws, which can occur on both small and large elm trees.
So even if a young tree isn't good for breeding, the beetles might still feed on it.
Exactly, and that feeding gnaw is all it takes to introduce the spores, so young trees are definitely still vulnerable to infection, even if they aren't prime breeding sites. That distinction is vital.
Got it. So let's zoom in on these beetles, these tiny architects of destruction. What species are we talking about, specifically in Denmark?
Good question. The notes say Denmark has 4 species of elm bark beetles, and importantly, all 4 can transmit the disease.
4 different kinds.
Yeah. The most widespread is the little elm bark beetle, Scolitis laevis. It's tiny, only 4.5 millimeters, barely bigger than a rice grain, and it's found all over the country.
A little bit deadly.
Indeed. Then there's the Manchestrabet elm barkbill, which translates to the multi-striped elm bark beetle, S. multistriatus. That one's found mostly in the southern parts of Denmark.
Okay.
And then you have the great elm bark beetle, which is actually 2 species, S. scolitis and S. triarmetis. Historically, these were mainly found in the east.
But that changed.
Yes. Here's an important point from the notes. Post-2000, these great elm bark beetles significantly spread north in Jutland. And this expansion directly correlated with elm disease becoming much more prevalent in North Jutland around 2013.
So beetle movement equals disease movement.
A clear link. It really highlights how the vector's distribution drives the disease's spread.
Let's talk life cycle. How do they keep going?
Right, the cycle is key to their persistence. They lay eggs under the bark on weakened elms, carving out those gallery systems.
Okay.
The newly hatched larvae then gnaw tunnels in the bark as they feed and grow. They actually overwinter as larvae right there in the bark, protected from the cold.
So they survive winter inside the tree.
Yes. Then they pupate in May-June as it warms up, transforming into adults. Hatching starts around 15 degrees C, but they first fly out when the air temperature exceeds 22 degrees C.
Specific conditions needed for dispersal.
Exactly. And weather plays a big role. Low wind speed and dry weather provide the best spreading opportunities. Lets them fly further more easily.
Makes sense. How many generations do they have a year?
It varies. The little elm bark beetle usually has only 1 generation per year. But the great elm bark beetle often has 2, especially in warm summers. The exact number and length of the flight period depend a lot on the weather that year.
Warmer summers mean more beetles, potentially.
Potentially more generations, yes. And here's something amazing about their resilience. Larvae of both species can survive temperatures down to national 30 degrees C.
Minus 30 Celsius.
Their body fluid contains glycerol. It acts like natural antifreeze, like what we put in cars.
Incredible. So what does that mean for controlling them?
It means you need an unusually cold winter to really knock back the larval population naturally. They are incredibly hardy. Natural control is very difficult.
Wow. Okay, so given this relentless enemy, what are the strategies? How do people fight back, or at least manage it?
Well, the approach from plant health authorities in Denmark has been realistic, pragmatic. The goal of recommendations is to eradicate infection sources and limit spread where possible.
But not full eradication.
No. The notes are clear. An actual eradication of Elm disease in Denmark was considered impossible from the start. Just too widespread, too effective.
So what did they do instead? Was it mandated by law?
No, combating it was not mandated by law. The focus shifted instead to information campaigns and publication of brochures, outlining the accepted recommendations for landowners, municipalities, etc.
More about guidance and awareness than strict rules.
Exactly. Acknowledging the scale of the problem and putting the responsibility more broadly on the community, encouraging best practices, collective vigilance, really.
Okay, so what are those recommendations? Does pruning help?
Pruning. It's a race against time. It may save the true, but only if the attack starts in individual branch systems, meaning it hasn't spread systemically yet.
And you have to be quick.
Incredibly quick. Immediate pruning is essential. Within 1-2 days after the first symptoms become visible, that's a tiny window.
1 or 2 days. Wow.
Speed is everything because the fungus moves so fast internally, and you have to cut correctly at least 1.5 meters below visibly attacked parts, well below any wilted leaves or stained wood, to be sure you get it all.
1.5 meters below, that's a lot.
It is, and tool hygiene is critical. Pruning tools should be disinfected with rubbing alcohol, especially after cutting into discolored wood, so you don't accidentally spread spores yourself.
So this high-stakes surgery, basically.
Pretty much. The warning is stark. Pruning must be carried out carefully and fast. Otherwise, it is futile and felling will still be necessary. It's a last-ditch effort, really.
So if pruning fails or isn't an option, it's felling, taking the whole tree down.
Yes, felling becomes the ultimate intervention. And again, timing is critical to prevent more spread. Diseased trees must be felled and removed before May 1st.
Well, before the beetles fly.
Exactly. Get them out before the new generation emerges. And in warm summers, attacked trees should be removed immediately because the great elm bark beetle might have that second generation spreading infection later in the season.
It's not just cutting it down, is it? What about the stump?
Good point. The stump must be removed, maybe by stump grinding, or at least debarked to 20 centimeters below the ground. You have to stop beetles breeding there, too.
And the roots, if it spreads that way.
Right. If healthy elms are nearby, the stump and roots should be removed entirely. Or you can dig a 1-meter deep trench between the diseased site and healthy trees to sever all root connections. A physical barrier.
Like a moat against the fungus.
Kinda, yeah. And for an alley, where roots are often interconnected, if the attack starts at one end, the recommendation is to fell the first healthy-looking tree next to the diseased ones too, just in case the infection has already spread unseen through the roots.
Taking out a seemingly healthy tree is a precaution. Tough call.
It is. And then there are transport restrictions. From May 1st to September 1st, diseased elm wood should not be transported, because beetles inside can fly out during transport and start new infections.
Makes sense. Any exceptions?
Only for diseased, but still living, trees felled in summer if they're disposed of immediately according to the rules.
Okay. Now, what about treatments? Is there anything like a vaccine?
Yes, the notes address this. That term vaccination is sometimes used, but it's really chemical control with a fungicide, not a true vaccine.
Okay, so chemical treatments, are they used in Denmark?
Here's the current situation. Currently, no agents are approved for treating elms in Denmark, specifically for elm disease.
None at all.
None approved for this purpose.
Yeah.
The one previously permitted agent, Alamo, propiconazole, is no longer sold, and the notes add that experiences in Denmark were not very good anyway, suggests limited effectiveness.
But people still want to try things, I imagine, to save trees.
Absolutely. The interest persists, and unfortunately, some companies seek to exploit this. You'll sometimes see praises of various treatments against elm disease on the internet making big claims.
Buyer beware them.
Definitely.
Yeah.
The crucial warning is, none of the mentioned agents are currently approved in Denmark and therefore not legal for elm disease control. They might be legal for other things, like soil improvement maybe, but not for treating this disease.
And is there any proof they work?
This is key. As a rule, there is no experimental or scientific documentation for the effect of the mentioned treatments for elm disease. Claims often just show pictures of treated trees without verifiable evidence. You need a good portion of skepticism when you see those ads.
Right. Unproven, potentially illegal, and likely ineffective. Doesn't sound good.
And it gets worse. Beyond just not working, there are significant downsides to chemical treatments. They can cause more harm than good.
Like what?
Well, firstly, large old trees are the most difficult to treat. It's really hard to get the chemical distributed evenly throughout the whole crown's vascular system. Protection can be patchy.
Yeah.
Secondly, they're not a one-time fix. Treatments must be repeated every year or every other year. Stop the treatment and the risk of attack returns. It's an ongoing, costly commitment.
Expensive, you mean?
Very. It's expensive, both in purchase price for the agent and in labor hours. The notes suggest it can prove to be more expensive than replacing the trees in the long run.
Wow. More expensive than just replanting.
Plus, these treatments often need qualified persons to perform them, requiring special training. If done incorrectly, it has poor effect on elm disease and can unnecessarily harm the tree.
Harm the tree how?
Directly. Trees are wounded by drilling holes for injection, creating entry points for other problems, and introducing chemicals into living wood can locally cause poisoning of the plant tissue.
Poisoning the tree you're trying to save.
Locally, yes. This can lead to visible issues like bark necrosis, dead bark patches, defoliation, and just general weakening.
And a weakened tree is more vulnerable.
Exactly. Ironically, weakened trees can possibly be used directly for egg-laying by beetles, even without having elm disease first. And other fungi can gain entry, like scaly polypore or elm grayleaf. Repeated treatments just increase the risk of damage.
It sounds like a risky proposition all around.
It often carries its own complex risks for the tree and the ecosystem. Quick fixes often aren't the best answer for these big ecological problems.
And it's not all doom and gloom, right? You mentioned hope earlier. Resistant elms.
Yeah. Yes. Amidst all this, there is a genuine glimmer of hope. Resistant elms.
They've managed to breed them.
They have. Now, there were earlier attempts, back when they were fighting the original fungus, O. ulmi, and they were successful then, creating resistant clones.
Oh.
But when the new, aggressive O. novel ulmi arrived, those previously marketed clones died on par with other elms. Back to square one.
Oh, devastating.
It was. But the good news is, several years of dedicated work to produce elms that will remain resistant in the longer term have now led to new elm varieties. Real progress.
Do you know any names?
The notes specifically mention New Horizon and Rabona.
New Horizon and Rabona, are they actually being used?
Yes, and successfully, New Horizon is planted in many places in Copenhagen municipality and appears to be doing well, thriving where older types died.
That's fantastic. A long-term sustainable solution.
It seems to be. Planting resistant varieties allows us to slowly bring elms back, addressing the core vulnerability through genetic resilience. It's really promising.
That is great news. Okay, last crucial step. Disposal. Once a tree is felled, how do you get rid of it safely?
Absolutely critical. The overriding objective is clear. To kill the elm bark beetles, which you have to assume always occur in the bark and possibly the wood of elm disease trees, eliminate the vectors.
Makes sense. What are the official recommendations?
The Plant Directorate provides a comprehensive list, all aimed at killing the beetles. Options include burning the wood on site, at incinerators, or in chip burners. Destroys everything.
Okay, what else?
Shredding and composting, but at a minimum temperature of 60 degrees C to kill beetles and fungus. Or chipping and covering with a tarpaulin for a minimum of 1 year, basically suffocating any beetles inside.
Covering chips for a year, okay.
Or firewood.
It can be used for firewood if it's kiln dried at a minimum of 60 degrees CC first. Kills anything hiding inside.
Kiln drying, important step, burying.
Deposition at a landfill is allowed, but it must be buried under a minimum of ½ meter of soil to act as a barrier.
½ meter of soil? Okay. You can also keep the wood submerged under water for 1 year. Drowns the beetles. Or, for newly attacked trunks, debarking is an option, but the bark must be burned immediately.
Get rid of the bark right away.
Yes. Debarked trunks can be cut into timber, though there's a certain risk that pupal chambers with living beetles may be found deeper in the wood, especially with the little elm bark beetle. So, some caution there.
So even debarked timber isn't 100% safe.
A small risk remains. And importantly, chipping itself does not remove the fungus or the beetles. It just makes smaller pieces. The treatment after chipping, composting, covering, is what kills them.
Right. That's a lot of options. Is there one overriding rule?
Yes. Perhaps the most critical rule for preventing spread emphasized in the notes. It must be emphasized that under no circumstances should elm wood with attached bark be transported further than the nearest power plant. Keep it local.
Don't move infected wood around.
Absolutely not, and a specific warning for the public. It is especially reprehensible to take elm firewood to other parts of the country.
Why is that so bad?
Because there are still places in Western Denmark where elm disease is only sporadically present, and there are areas where consistent control has kept the disease reasonably in check. Moving firewood could introduce the disease to these less affected areas, undoing years of effort.
Individual responsibility is key then. Protecting those last refuges.
Immensely important. A single thoughtless act can have huge consequences.
Wow. What a journey. We really covered a lot today, tracing this whole story of elm disease.
We really have.
From Kesser and Steen's sharp observations kicking things off, and again, massive credit to them. Their notes were fantastic. Such a great starting point.
Absolutely.
To the complex biology of the fungus and beetle partnership, the dramatic global history, the spread, and then the ongoing battles, the management efforts, and thankfully, the hope offered by resistant varieties.
It touches on so many things.
It really does. The core lessons for me are about these intricate, sometimes devastating ecosystem interactions, the huge role humans play, often unintentionally, in spreading diseases, and the mix of science and practical steps needed to face these challenges.
And if we connect this to the bigger picture, the story of elm disease is such a powerful lens, isn't it?
How so?
It helps us understand broader issues, like the delicate balance of nature and how vulnerable it is to introduce species. The long-term, often unexpected fallout from globalization, from trade and travel.
Yeah, definitely.
And the need for different fields to work together, biology, economics, urban planning, public communication, to tackle complex environmental problems. But also, you see nature's resilience alongside human ingenuity finding solutions like those resistant trees.
Resilience and innovation. That's a good takeaway.
So maybe a final thought for you, our listener. What really stands out to you about how human actions, even small things like moving firewood or importing timber without thinking, can have such profound, lasting impacts on our natural world? How does this deep dive change how you see the links between global ecosystems and your own local landscape?
That's a great question to ponder. So what does this all mean? It means the world is just packed with these fascinating interconnected stories, waiting to be uncovered, often right under our noses, like with our neighborhood trees. We really hope this deep dive has opened your eyes to one of them, maybe sparked your own curiosity, and encouraged you to keep exploring with us.
We hope so.
And if you found this deep dive as informative and, well, fascinating as we did, please make sure you're subscribed to The Deep Dive wherever you get your podcasts. That way you won't miss any of our future explorations into incredible knowledge and surprising insights.